Hello and welcome to Global Climate Change. This is lecture 2, and today we're going to be going over the difference between the Earth and Venus. Okay, we can look at these two um, globes or these two planets and actually discover some things about their climates and the atmospheres and how the sun actually hits them and make some, ideas or come up with some ideas on actually how global climate change can affect each climate, even though they're completely different and they're different lengths from the sun and they receive different amounts of sunlight. We'll kind of go over albedo as well, and as well as their atmosphere. So when we're actually going over this, there's going to be a couple things that you're going to want to consider. One being which planet is closer to the sun. Another one is which planet is more reflective. And the third thing is going to be which planet has a larger ability to absorb and retain solar energy. Argos is running around behind me. I don't know if you guys can see this, but it's kind of cute. Okay, so first of all, which planet is closer to the sun? You can see actually from this depiction here of our solar system that Venus is right here and Earth is going to be a little bit further away from the sun right here. So, we can deduct from this idea that Venus is going to receive more sunlight. Okay, the source of energy that each planet is going to receive is going to be mainly from the sun. Okay, the sun radiates energy in the form of radiation. Okay, and the energy radiates out with distance. So basically, the sun is going to project the sunlight or the radiation out from it. The planet is actually going to receive that sunlight, and then it's actually going to have its own amount of radiation that it radiates out as well. Because anything that actually has a temperature associated with it will actually emit energy or radiation or heat or energy. Okay, so we have the Earth and we have Venus. We've already established the fact that Venus is closer to the sun. So what's going to happen is that Venus will actually receive more radiation and it'll actually receive a stronger radiation. So the sunlight strikes Venus is actually 93% stronger than the sunlight that's striking the Earth. Okay, we would expect Venus to be warmer then, right? Because if Venus is closer, Venus is receiving more sunlight, 93% more. That's quite a bit more. So we would expect Venus to be warmer, based solely on the position of Venus, nothing else, not the other two things that we were talking about earlier. Okay, so if it was based only on the distance of the sun, then Venus would be somewhat warmer than the Earth. And the average surface temperatures would be as follows: if the planet absorbed all of the incoming sunlight. The Earth would then be 41 degrees Fahrenheit, and Venus would be 131 degrees Fahrenheit. That is really hot. But it isn't exactly that way, because we also have those two other points that we should go over here, and that might change this. So, however, Venus and Earth do not absorb all of the incoming sunlight. Okay, part of the incoming sunlight is going to be reflected back into space. The Earth actually reflects 30%, and the Venus reflects 70%. Now, this actually leads us to an important concept. This concept being albedo. Albedo is going to be the fraction of light reflected by an object or a surface. Now, this really matters because when something absorbs the light or the radiation, then that means it's actually going to have a warming effect. But when it reflects it, then it just bounces off. It doesn't actually warm up that being or that body or that planet. So white objects like snow or ice have high albedos. So if you ever go skiing in Tahoe and get sunburnt, and you're like, it's cold, there's snow, like what's going on here, right? It's because white objects like snow have high albedos and they reflect the sunlight off of them. So that sunlight's going to come in and it's going to reflect off of the snow and it's going to hit you and possibly give you sunburn. Hopefully not. You'll wear sunscreen, so it's not going to be that big of a deal. Okay, but black objects like dirt, like, I don't know, crops, I don't know. I have a white dog, but if you had a black dog, then it would actually have a low albedo. Okay, that's actually going to absorb sunlight. We know this because if we wear something that's black, we're going to get hotter. And if we wear something lighter, then it's going to reflect it off and we actually won't get as hot. If we have, for instance, black interior in our vehicles, then that can really, really heat it up. And then it would be hot to sit on, like black leather if we go and sit on it after our car's been sitting in the sun. Versus if we have like tan or white leather or something like that. Okay, so what does this whole business of albedo have to do with our comparison between Earth and Venus? Okay, Venus is completely covered by highly reflective clouds. So that means that it actually is going to take that sunlight, even though it's closer to the sun, but it's going to take a lot of that sunlight and actually reflect it off. But Earth is actually partially covered by clouds. The other part is going to be ocean, which is blue, and blue is my favorite color. So anyway, the Earth is partially covered by clouds and makes it less reflective, but more absorbent. So that means that the Earth is actually going to absorb more sunlight and therefore actually get warmer. Which planet has this higher albedo? That's going to be Venus because it has the more reflectivity to it. Earth's albedo is actually going to be 30%. Only 30% is actually reflected, where Venus actually reflects 70%. Okay, Earth absorbs 70% of the sunlight that strikes it, and Venus absorbs 30%. That's just another way of saying that. So let's re-examine the surface temperatures with this new information. Let intensity of sunlight striking the Earth be denoted by 100. Okay, in these units, intensity of sunlight striking the Venus is 193. The Earth absorbs 100 times 7.7, which equals 70 units. But Venus absorbs 193 times 0.3, so that's going to be 58 units. That means that the Earth absorbs more energy from the sun than Venus does. Okay, wait. So the Venus is closer to the sun, which would mean that it'd probably be hotter than Earth, but Earth absorbs more of the sun, which means that it maybe would even out in the end. So let's get to the last point. The last point is which planet has larger ability to absorb and retain solar energy. If a planet's mean surface temperature were determined solely by the amount of absorption of solar radiation, Venus would actually be colder than Earth. Kind of crazy. But based on average measurements combining surface air temperature and sea surface temperatures, Earth's mean surface temperature is actually 59 degrees Fahrenheit. Perfect for humans. Venus' mean surface temperature is about 896 degrees Fahrenheit. That is hot. So, Venus absorbs less sunlight than Earth, yet Venus' surface is much hotter than Earth's. Why? Again, we're going to go back to this last point. Okay, the rate of absorption of sunlight can be calculated from outer space. The distance to the sun and albedo are all the things that are required. Okay, we can actually calculate this. Surface temperature is not correctly predicted from rate of absorption of sunlight. So what could cause such a difference? That must be this third idea that I keep mentioning, right? The respective atmospheres. The atmosphere is going to be the difference between Earth and Venus and the reason why they are the temperature that they are. So if it's the atmosphere, then what are they made of? Like what's causing this, right? It's going to be the different gases that they're actually consist of. So Earth is going to be mainly nitrogen, mainly by far nitrogen. And then we're going to have some oxygen and a little bit of argon, a little bit of water vapor, and a little bit of carbon dioxide. Water vapor and carbon dioxide actually are trace gases. Okay, but Venus is going to be mainly carbon dioxide and nitrogen. Okay, if we actually look at it, Venus's atmosphere is way bigger. Okay, it's actually 10 to the 18th bigger. Okay, that's how big this is. But since it's mainly CO2, we're talking about a lot of CO2 that Venus has in its atmosphere. Where Earth doesn't really have that big of an atmosphere. And if you look, it's only 0.06% CO2 of our total atmosphere. So we can conclude that Venus has much more massive atmosphere than Earth, and that is mainly CO2. The mass of CO2 in Venus's atmosphere is almost 100 times as great as the total mass of Earth's atmosphere. Okay, so that's crazy to really think about. There's more CO2, there's 100 times more CO2 in Venus's atmosphere than the total mass of our atmosphere. But why is it so important that it's mainly CO2? CO2 is actually a greenhouse gas. Greenhouse gases are those gases that cause the greenhouse effect. Now, you guys probably have heard about the greenhouse effect. This makes a planet's surface temperature warmer than it would otherwise be. Okay, the stronger the greenhouse effect, the warmer the surface, with other factors being equal. So it's kind of like a greenhouse. The sunlight comes in through the glass, okay, it's transparent to that incoming sunlight, but it's not transparent to the heat. So it won't let the heat escape. So then that heat is actually trapped inside of the greenhouse. So that's why they call it the greenhouse effect. Venus's atmosphere contains around 25,000 times as much mass of greenhouse gases as Earth's. Wow. So they got a lot of CO2 and a lot of greenhouse effect going on. Let's see. Thus, Venus has a much hotter surface than Earth, despite the fact that it absorbs less sunlight. So basically, it's really got a lot of greenhouse effect going on. So not like the sunlight comes in and then it's not able to escape actually because the atmosphere won't let it escape. And what does this have to do with climate? The greenhouse gases like CO2 play an important role in determining surface temperatures. The change in greenhouse gases can increase or decrease surface temperatures, and that happens actually all the time here on Earth. Without the greenhouse effect, the surface of temperature of Earth would be very cold. It would be 0 degrees Fahrenheit. More greenhouse gases mean a warmer climate. Less greenhouse gases mean a cooler climate. By itself, actually, the greenhouse effect is a good thing. Because without it, like we said, our temperature would be 0 degrees Fahrenheit. I mean, that's too cold for us here. Okay, we don't want it that cold. We actually want it warmer for us to live here so we can grow crops and we can eat them and we can have animals and we can have all the different things that we have going on. Plus, we'd freeze to death. But global warming is the result of an enhancement of the greenhouse effect. Okay, over time, atmospheric concentrations of greenhouse gases have actually increased because we've been putting extra greenhouse gases into the environment more than just what naturally occurs. So this has led to the warming of the planet. That's all I have for you guys this week. I hope you have a terrific week. We had a very short week, so that's pretty cool. I'll see you guys next week. Bye.